Hello and welcome everyone. Today I'm diving deep into the Backgammon Elo system, as implemented by FIBS, Backgammon Studio and Galaxy. I know it sounds boring and bookish, and maybe it is, but the results are interesting. That being the case, feel free to hop straight into the summary and return only if you get an urge to cross some eyes. And for the few of you brave enough to join me in the arena, I salute you. Either way, please offer a like to that big algorithm in the cloud. The Elo system for backgammon was developed by chess master Larry Kaufman. Kaufman wrote an article in '91. FIBS creator Andreas Schneider saw it, liked it, and used it in FIBS, the first internet backgammon server. Later, it tumbled down into Backgammon Studio. This is the main formula, which converts rating difference into match win probability. It differs from the standard chess formula, which I describe in another video, link below, in two ways. First, it uses a scaling factor of 2000 instead of 400. This is a technical, pragmatic change. It's just a scaling factor. Simply divide the Elo difference by 5 to move from backgammon to chess, and multiply it by 5 to turn chess Elo into backgammon. It was done to offset the second, conceptual change. Users on backgammon sites can play a 1-point match, 25-point match, and anything odd in between. But obviously, have just one rating, not 13. 13 is unlucky and backgammon players won't stand for it. And the longer the match, the better the odds for the stronger player, because luck has more time to average out. Kaufman decided to use the square root of n, the match length. A rating difference of 34 Elo for a 1-point match gets multiplied by the square root of 7 to obtain the Elo difference in a 7-point match, 90. The 5 times factor, 400 to 2000, is meant to equate the backgammon 25-point match with skill-only chess. All nice and tidy, but why the square root? The article is not available online, but I managed to contact Kaufman, who kindly passed me to backgammon giant Kent Goulding, who sent me to another legend, Bill Roberti, and he scanned it for me. It turns out that the square root of match length was used for similar reasons to its use in Brownian motion or in the Black-Scholes options model. It seems to be the accepted way to model similar random-ish events that take n random steps. So no backgammon theory and no empirical data. Awesome! I get to go on a small quest, take a selfie with dragons, and return with a tail. But it's a messy tale. You know how it is with dragons. So let's start with something cleaner, a simplified tabla match. A tabla match is also a series of games towards a total of 1, 3, 5 points, etc. But there's no gammons and no doubling cube. In this simple setting, it's straightforward to compute the probability of winning the match from the probability of winning a single game. This figure shows the relation between different match lengths. If you beat me 60.6% of the time in single games, 75 Elo points difference, then you win 68% of our 3-point matches, 142 Elo points, and 86% of our 13-point matches, 317 Elo points. Please note that I'm using the chess scale, 400 Elo points for 90% wins, and I'll let you know when I switch to 2000 or something else. This tabla figure shows a pattern that pops up again and again. Strong players tend to get stronger faster. The larger the skill difference in some simple game, the better player gains in the longer, more advanced game. Now, does tabla matches follow the square root ratio? Here is the Elo ratio for the 3 and 5 point matches, and the answer is a clear no. The ratio is bigger and also varies with the Elo. And here are the ratios for match length up to 13. If they follow the square root, they would be flat at 1, the red line. But they start around 1.1 times the square root and climb. The longer the match, the faster the ratio climbs. That is, the longer the match, the less it adheres to the square root hypothesis. This discrepancy between model and data shows up as bias. Say Alice is 75 points stronger than Bob, and they play a random mix of 3 to 13-point matches on FIBS or heroes. Their rating difference average over time would be about 88. And this bias, as usual, grows with the skill difference. At 200 it's around 60. Does it matter? No, because a match without gammons or a doubling cube is not backgammon. This is just a tidy error example meant to demonstrate what can happen when model and reality clash. To see what happens in backgammon, we need data from actual backgammon games. Data I don't have. Backgammon sites keep their data safely in Gringotts, so I had to conjure some on my own. And it's not trivial. We want games from a mix of players, strong and fast players. Strong so that the results would be relevant, and fast because we need many matches for a variety of lengths, from 1 to 13 points. I had one such player, GNU-BG at 0 ply. For the rest, I fiddled around with new neural nets and eventually settled on 6 new players and put them to work. Every player got to play all the others, 20,000 1-point matches, 20,000 3-point matches, and so on, up to 13, a total of almost 3 million matches. Not enough to nail down the Elo at each data point, but plenty for the big picture. Let's look at the player's Elo first. Assuming that ZP, to pick a number at random, is 2000, these new nets are spread nicely down to 1850. Please remember that these are 1-point match Elos, chess scale, and since 150 times 5 is 750, it's equivalent to, say, 1100 to 1850 on FIBS or Heroes, from weak players to bots. Nice indeed. Nice as in that will do, donkey, that will do. Also remember that the interval grows with match length. It spans from 1750 to 2080, when those same players play 13-point matches. Excellent. So how do they stack up? Well, folks, welcome to the real world. Compare that with the same figure for our simple Tavla matches. But don't weep, it's not as bad as it looks. First, we have one really interesting case, where the Elo difference actually decreases with match length. This happens, I think, because Alice and Bob are almost equal in strength, but Alice's checker play is slightly better than Bob's, and her cube actions are slightly worse, and cube importance grows in longer matches. Still, even at 13 points, Alice is a small favorite. You can take it as anecdotal evidence that checker play is more important than cube play. It doesn't change the big picture, because this anomaly can happen only with very closely matched computer players. Humans can't play 30,000 matches at each score to find out. All the other pairs exhibit more or less the same trend. It's even better than that. All those curves can be fitted nicely with a quadratic line. And maybe more interesting, the coefficient of those seem to be linear, pretty much. So we actually have a model that can generate the match ratio for any arbitrary Elo. I plotted 3 examples for you in red. I wasn't expecting this, and we should add more data points before celebrating. But it's a really good sign that the results will be meaningful. So what do we have? Square root or square 1? Here are the results for the 3 and 5-point matches, and it doesn't look good for the square root. The ratio is significantly lower, and if we ignore the first 2 very closely matched pairs, it seems to settle to a constant value. Same story for the other match lengths. This might explain the regularity we just saw. The change in Elo has very little effect on the ratio. And if it's constant, we can take the mean values, the dashed green lines, and plot this curve in blue against the square root curve, shown here in orange. And again, it can be fitted very nicely with a quadratic formula. Now, we can translate the skill difference of any 2 players at any match length to any other length. It's so nice, it deserves a name. Let's call it the B line, B for bots. Yip yip hooray! Okay, now is a good time to calm down and reflect. How did we get here? We ran the experiment, collected data, and fitted it with linear and quadratic polynomials. Based on visual inspection, there's no theoretical justification. The curves might be exponentials or logistic or logarithmic or something else. The number of data points is way too low. Still, I think it's safe to rule out the square root hypothesis. You might disagree. Perhaps humans don't follow the same patterns as computer players. Maybe the ratio does change with Elo and it makes a difference. Maybe the B-line is a square root of a simple function of match length. Valid objections. But I do believe that those patterns will show in human play. The rise of PR-assisted scoring pressures strong and medium players to emulate and follow bot play as closely as they can. There's also the possibility that the theory is off, but the effect is too small to worry about. It's easy enough to test. Just throw our players, which follow the B-line, into FIBS and see how reasonable their estimated Elos are. Let's look at Alice, Bob and Chuck with Elos 1400, 1600 and 1700 who play 3, 5 and 7 point matches. Here's a trace of the rating and the average over time. An open and shut case, right? Not so fast, Counselor. It turns out that the estimated Elos just got squashed. Bob is still at the 2/3 point between Alice and Chuck, same as for the true Elos, where the differences were 100 and 200. So little harm done. Again, not so fast, members of the jury. Let me first explain the circumstances, and then we'll discuss damages. Get some coffee, because it will be confusing at first. Let's focus on Alice and Bob, 200 Elo points apart. Think of the blue line separating them as walls, adjustable walls, and the Elo flows in. There's an outlet which outputs 1 Elo in 1 unit time. So when Alice and Bob play 1 point matches, 200 goes in and the walls expand to 200. And if the Elo difference was 400, the walls would expand to 400. Now, what happens when they play 3, 5 and 7 point matches? Now, 3 streams are coming in, so let's set the outlet at 3. Each stream comes at a different rate. The 3-point stream comes at 258, 200 times 1.29, where 1.29 is the 3-point match multiplier from the B line. The 5 pours 309 and the 7 354. And now, in a well-designed system which knows about the correct values of the B line, each stream goes into its own flexible tray, whose size is proportional to the B line value. This balances the 3 streams, and the walls expand to 200, the correct value. But FIBS put trays of sizes square root of 3, 5 and 7. Now, the stronger 7-point stream can pump more relative to the others, and the system settles on 140. It says, in a way, if the streams were coming in at the square root ratios, then a base value of 140 would explain the total influx that I see. And as you can see from the equations, the 200 appear just as a multiplier. Every Elo would get just multiplied by 0.7, which explains how the 2-to-1 ratio between Alice and Bob Chuck remains intact. No magic needed. And you might have realized there's nothing special about the square root. You can use weights like 3, 5 and 7 or anything else, and the system will find values to match. And it works for any number of players. Take those 50 players, Elo in blue, pass them through the FIBS system, and get the estimates shown in orange. Stretch them, and they will match the true values. There's only one tiny problem. This adjustment depends on the mix of match lengths. Every mix has its own stretching factor. Here's what happens when Alice, Bob and Chuck play different mixes. I'm showing just the range Alice and Chuck Elo difference because Bob is always at the right place. As you can see, the range varies between 223 for 3-point matches to 185 for 13-point matches, with lots of options in between. This means that 2 players of equal strength will have different rating if they play different mixes, and that players can game the system by choosing shorter matches, which seems paradoxical, but it's just because the 3-point multiplier is closer to the square root than the 5-point multiplier is, which is closer to the 7, and so on. So how big a problem is it, if at all? I don't know, because it depends on FIBS and heroes playing patterns. If all users play the same mix, the effect is minimal, just a reduction in range. If not, the effect might be big. And here I should point out that the solution is trivial. Look at real data, decide if humans follow the B line or something else, and use the correct multiplier, the correct m in the formula. A good programmer can replace the square root with a beeline in 5 minutes, including a muffin break. And then we won't have to worry about this problem again. And speaking of problems, let's turn to Backgammon Galaxy. Officially, the Galaxy rating formula is a state secret, but data loves to be free, especially with talented researchers like Chris Yep. Chris reverse engineered the formula 3 years ago, and I'm sure it wasn't easy. Just look at all those spikes, especially the formula for K. Really amazing work, Chris. And you, being a quick learner too, immediately noticed 2 things. First, Galaxy uses a factor of 800. Okay, you say, they choose whatever makes Elos fit inside the range they like. After all, it's just a scaling factor. Too bad they didn't bother telling anybody. The second, more disturbing detail was the absence of the square root. And it can't be a careless omission. Nobody fiddles like that with the process. Engineers K, puts a factor of match length to the power of 0.75 in the update, and somehow forgets to enter the term that really counts. Because no amount of mucking around with K will compensate for the difference in match length. K controls bias and the size of immediate reward, and the bias of the Elo estimate, but not skill level. This troubled me for a while, but I think I found the reason. A Galaxy win requires a match win and a PR win, and the square root compensates only for the match win. To compensate for both, you need to model how PR relates to Elo, which neither Galaxy nor anybody else knows how to do. This is actually a serious drawback of the PR system, one I wasn't aware of until now, and one which makes it impossible for me to objectively evaluate the system. No doubt the omission matters. Take Alice and Bob. In 3-point matches, Alice wins the match 60% of the time, and the PR 73% of the time. This gives her, in Galaxy, a 493 Elo points advantage over Bob. But if they played exclusively 5-point matches, her advantage would be 527, and 556, 580, and 603 for 7, 9, and 11-point matches, respectively. She simply does not get enough credit for her 3-point matches. The system only sees the 60% win rate, as opposed to a 66% win rate in 11-pointers. And let's leave it at that. There's no point in probing a system lacking a clear model. It does what it does. FIBS has a model. It's probably off, but can be easily fixed. And in Galaxy, until someone comes with a realistic model connecting Elo and PR, there's no fix and no useful comparisons. And this upbeat and cheerful note leads us into the executive summary. 1. The Elo system for backgammon was developed in 1991 by chess master Larry Kaufman, when backgammon was entering the fledgling online world. Overall, it is a big success and used unchanged until today, first by FIBS and later by Backgammon Studio and BMAP. 2. Kaufman adapted the chess formula by introducing 2 changes. First, the scale was widened from 400 to 2000, and second, a factor of square root of the match length was added to compensate for the larger skill difference in longer matches. Together, they equate the backgammon 25-point match with skill-only chess. 3. The square root correction was introduced on general grounds, because it is common in random processes that take n random steps, such as Brownian motion or in the Black-Scholes options model. 4. My 7-year-old laptop is hundreds or thousands times faster than my 91 workstation. Enough computing power to test assumptions that couldn't be tested 30 years ago. Let's examine this square root hypothesis. And yes, I still miss my fabulous 91 keyboard. 5. Real testing requires strong and fast players. Strong so that the results are relevant to high-level human play, and fast because we need to run many matches at various match lengths. I used GNU BG at 0 ply and 6 other new neural nets. Together, they span a range of 150 Elo points for 1-point matches. Each pair played 20,000 1-point matches, 20,000 3-point matches, 20,000 5-point matches, etc. up to 13, a total of almost 3 million matches. 6. I totaled the wins and losses from the 3 million matches to find the Elo ratio at different match lengths. Somewhat surprisingly, this ratio does not seem to depend on the Elo difference itself. This allows us to draw the B line, B for bot, which shows the presumably constant empirical ratio. Turns out it is 75% or 60% less than the square root. 7. Assuming that humans follow the same trend, what are the implications? Unfortunately, there is no simple answer. It's not simple because the Elo system can adjust by rescaling the rankings. For 3 players with true Elo ratings of 1400, 1600 and 1700, the FIBS hero system will generate respectively 1450, 1590 and 1660, which have the same 2:1 ratio of spacing. 8. But there's a catch. The adjustment depends on the specific mix of match lengths. The same players playing different mixes will have different ratings. In our small example, the range spans from 185 for 13-point matches to 223 for 3-point matches. So the overall discrepancy depends on how regular the play patterns are among users. 9. On the good news side, it's easy to fix. Use the correct multiplier in the Elo formula. This could be based on simulations or real data, preferably both. 10. On the bad news side, there's Backgammon Galaxy. Turns out there's no compensation of match length in the Galaxy formula, presumably because of PR. A correct formula for the PR plus win system would need to model the player PR as well, which currently, as far as I know, no one knows how to. This means it is not really possible to evaluate the Galaxy system, but we know it shares the same problem of rating being dependent on the choice of match lengths. Alice and Bob, 493 Galaxy Elo points apart when playing only 3-point matches, will be 600 Elo points apart if they play 11-point matches. The fix, if any, requires analyzing real-game data, which Galaxy keeps safe in Gringotts. 11. In short, inaccurate compensation of match length or no compensation at all. Both degrade the quality of the Elo estimates and make it harder to interpret the ratings, as they depend on what match lengths each user likes to play. Time for final thoughts. The Elo system is a great success and used in various sports. Backgammon poses a unique challenge because players battle both dice and opponent and is in fact a set of closely related games. The need to tweak the Elo system was identified by Kaufman and led to the system we use today, but the key assumption was never seriously tested. The results I obtained suggest that the theory is off, but it's easy to fix. Use the correct match length multiplier. However, this applies only to sites using Kaufman original formulation. Backgammon Galaxy chose a different path, and while PR is a novel idea and greatly contributes to reducing the role of luck, especially in tournaments, I feel that not enough thought has gone into adapting the Elo system that goes with the win plus PR scoring. No one will stop playing in Galaxy or any other site because the ranking system is imperfect, but it's important to have the basics right before worrying about shiny gadgets. End of rant. Thanks for listening, and I'll be back with more. Until then, roll the rigged bones and be happy.